And I would like to conclude this presentation by showing how the sample size can be estimated using the information from the confidence interval. To do that, we will use the formula for sampling error, which is nothing else but something we've already seen. Those are the elements that we added or subtracted from the sample mean to construct the confidence interval. So the critical z-score for the significance level of alpha over 2 multiplied by sigma, which is population standard deviation, divided by the square root out of n sample size. Or if we don't know the true population standard deviation, we can always approximate it using sample standard deviation. And then we take this equation, we rearrange it to get an expression for n, the sample size, and we get the following formula. So squared z-score multiplied by squared standard deviation, which in this case will be just variance, divided by squared sampling error. Or if we don't know the population standard deviation, we approximate it using sample standard deviation. So let's have a look at the example. Suppose the manufacturer uses a machine to inflate the new balls to a pressure of 13.5 pounds. The mean inflation pressure is 13.5 pounds and standard deviation is 0.1. For quality control purposes, the manufacturer wishes to estimate the mean inflation pressure to within 0.025 pound of its true value with a 99% confidence interval. What sample size should be specified for the experiment? So given this description, we can get the following information. So we know standard deviation 0.1, and it will be population standard deviation, because here we talk about all the balls that has been produced by the manufacturer. We also know the sampling error, which will be 0.025, because we know that the manufacturer doesn't want the mean inflation pressure to be outside 0.025 pound of its true value. So the error can be either plus minus this value of 0.025. And since we're asked to use a 99% confidence interval, we can get the significance level, which will be just 1% or 0.01. And the critical z-score value for 1% will be 1% over 2. This will be the critical z-score for 0.005, which we can get from the table of critical values, and we know that this is equal to 2.575. So we use the formula for the sample size that from the previous slide, from the slide before the previous slide. So we substitute everything into the equation and we get the sample size of 106.09. So approximately we can say that the sample size should be around 107 balls. So the manufacturer should select 107 balls. And now let's see how we can determine the sample size using the information about the confidence interval for population proportion. So similar to the case of population mean, first we need the equation for sampling error, which is nothing else but just the factor that we added or subtracted from the sample proportion. So the critical z-score multiplied by the square root out of PQ divided by n. After we rearrange this equation, we get an expression for n, which will be squared z-score multiplied by the product of PQ and divided by some squared sampling error. As we've already seen, most of the time we don't know the true population proportion, therefore we can approximate it using the sampling proportion, so P with the hat. So let's have a look at the example. So for example, a cell telephone manufacturer has an initial problem with excessive customer complaints and consequent returns of cell phones for repair or replacement. The manufacturer wants to estimate the magnitude of the problem in order to design a quality control program. The producer believes that no more than 10% of cell phones are defective. How many cell phones should be sampled and checked in order to estimate the fraction defective to within 0.01 with 90% confidence interval? So using this description, the following information can be obtained. So first of all, we know the population proportion. This is what the producer believes to be the true proportion of defective cell phones, 10% or 0.1. We can calculate the value of Q based on the value of P, which will be just 1 minus 0.1, so we get 0.9. We also know the sampling error because we know that the manufacturer or the producer wants the fraction defective to within 0.01. So the proportion can be either plus minus 0.01. Since we're asked about 90% confidence interval, the significance level will be just 10% or 0.1, and we will use the table to get the critical z-score value, alpha over 2 or 10% over 2. So the critical z-score for 5%, which is 1.645. And after we put everything into the equation for the sample size, we get the value of 2,435.42, which we can approximately say is equal to 2.436. Therefore, the conclusion is the manufacturer should sample 2,436 telephones in order to estimate the fraction defective to within 0.01 with 90% confidence.